Hello, so today we are going to do this problem, which is part of Leetcode daily challenge, maximum twin sum of a linked list. So with this problem, we have a linked list of size n, and this n is even. The ith node of the linked list is called the twin of the n minus I minus ith node. So basically, the node at position I is called the twin of the node at position n minus I minus 1. Yep. And for this, of course, to be valid, we need I to be between 0 and n divided by 2 minus 1 inclusive. And so if n equal to 4, the twin of node 0 is going to be node 3, because that would be n minus 1 minus 0, right? And node 1, the twin would be node 2. And so we define the twin sum as just the sum of these two values, the value and its twin, the node and its twin, the values of those two nodes. That's called the twin sum. And the goal of the problem is, given a linked list, we want to return the maximum twin sum. Okay, the maximum, if we take all the twin sums, what's the maximum value? And the linked list is guaranteed to be even, so we don't need to worry about a case where there are no separate twins, right? Because if we had 3, let's say just this, then we could make these twins, but we have to make these twins, or maybe these twins, so one pair would contain two pairs will contain the same value, and so that would be tricky. And so we are guaranteed here that we have we have only even length, so that means we can pair into independent pairs. Okay, so that's the idea here. Now if we take a look at this first example, 5 4 2 1, well, we pair 0 with 3. Again, that's the formula here, n minus 1 minus I, and then we pair 1 with 2. Okay, and so if we take the sum 1 plus 5, that would be 6. And then 4 plus 2, that's 6. The max between 2 is the 2 is 6. Okay, if we take the second example here, we pair these two, and then we pair these two, so that would be the max between 4 and 7, and so the max is 7, right? So that's the idea here. Now let's take a look at how we can tackle it. Okay, so let's see how we can handle something like that. So let's take the example where we have 4 5 4 2 1. Okay, so the simplest solution to do, right, is to just convert this to a list. So we'd have 5 4 2 1, and then with a list it's easy to get the indices, right? We can just take the index I and index n minus 1 minus I, right? So that would be for 0, it would be so for 0, that means here we'll take this, and then n minus 1 minus I, that would be n minus 1 minus 0, which is 4 minus 1, so 3, so that's this one. And then for the second one, again, this one, n minus 1 minus I, it would be n minus 1 minus 1, so it would be this one, right? So it would be really easy if we convert it to a list, but that solution is O of n time. Okay, you could also do it differently. If you want, instead of like doing the entire list, you could have a stack of values, right? You could put 5 4 2 1. Okay, and now you could traverse the node list again, and each time you pop this one and then you add it to this. So you pop, you add 5 plus 1, and then now this is gone, you pop 2, and then you add the next one plus 4. But you need to stop at the middle, so you need to stop at the size divided by 2, because we are already taking those here as part of the traversal of the linked list. And so that would give you the max would give you 6. So that's also another way to solve it, but this one is still O of n, because we are using this this stack extra space, right? And so how can we avoid this O of n time? O of n space, because of the extra list. Well, the main idea here, just to actually see it, let's grab a bigger example. So let's say we have 6 5 4 3, so this is 3 2 1, so the length is 6, which is even, so we are good. So the idea here is, let's just take, what are we doing? We want to pair this one with this one, pair this one with this one, and then pair this one with this one, right? Okay, and so if you look at it differently a little bit, if we reverse this side here, right, and get it to be 1, 2, 3, then at that point what we can do is just pair this one with this one, this one with this one, this one with this one. So in that case we can just start 2 pointers. Let's call this left, let's call this right, and we can just keep advancing these pointers, right, and just adding the values together. So if somehow we are able to reverse the second half of the list, then it should be easy. If we do this in constant space, sorry. If we do this in constant space, then it should be easy to do this in constant space, because we'll just traverse the linked list. Okay, and so now our problem is just to reverse this linked list. How do we do reversing a linked list? Well, that's just a known problem. There are other Leetcode problems that ask us to just reverse a linked list, but the main idea is, let's say you are at a current node here. So if then you just, for 2, for example, let's say our current node is actually here, then what do we need? Well, we need to just reverse the link. We need to remove this one and make it point like this. So what is this one in relation to the current? It's just the previous node. Okay, and so if we just write this more generally using like a previous node and then a current node with a link like this, what we are actually doing is just making the current.next point to prev, right? And then to move to the next one, we put current to be current.next, right, to go to the next one. And then we want to put prev at this point here, at the previous current, right? And so we remove this, and that's pretty much what we are doing, right? So if we have, let's say, 3, 2, 1, what we'll do is we'll make 2.next become 3, right? That's what we are doing here, making the current.next become prev. And then making prev becomes 2, right, for the next iteration here. Okay, and then making current, which was 2 before, become 1. Okay, and now once we do that, we do the same operation again, and now the 1.next becomes 2. And so at the end of this iteration, we'll have 1 pointing to 2 and then 2 pointing to 3. Okay, and so what are the operations we did here? We just said current, let me actually write this in a more, so we want to say that current.next is going to be prev, okay, is going to be prev, and then we want prev to move to the current position for the next iteration. So prev here is going to be equal to current, and then what's the other step? We want current to be equal to current.next so that we do the next operation. So current is going to be current.next. Now I'm intentionally doing those in the same line in Python, because if we do this in Python, then it will take care of creating all the temporary variables, so that when we assign this prev here, it will be assigned before we update prev. If we don't do this, if we want to do this with another language, you would have to create temporary variables and have store first in the temporary variables, then assign. But in Python, if we do it in this way, prev here, the prev here would be assigned to current.next before we change prev. So that will make it work. But this is the overall idea of reversing. You just run it on a small example, and you can generalize by removing the values and just adding a notation here. Cool, so that's the idea, and with this solution it's of one space, but still of in time, because we have to traverse the entire thing. Once we reverse, it's easy. We just have a pointer to the front here and another pointer to the middle, and we just traverse. Now your question becomes, how do we get access to this middle here to know when we start reversing, right? Well, that's also again another known problem, right? To get to the middle of a linked list, we just use a known algorithm called I think tortoise and the hare. But the idea basically is you have 2 pointers, slow and fast, and slow moves just one by one, okay, each time to the next one, but fast moves twice by 2 nodes each time. And so fast, each time you assign fast.next. And the idea here is once this fast reaches the end, slow will be at the middle. let's run it on an example and see if that's actually the case. So let's take just this list here, copy it, and put it here. And now let's run it on it. So if we use that, then our fast pointer slow would be here. And let's say maybe also we put our fast pointer at initially at the same position, right? But each time slow moves once, and so the first time slow moves once here, and then fast needs to move twice, so it moves here. Okay, and then we move another iteration, so fast becomes here, and then slow just moves to 4. Okay, and then we move again our fast 2 times, and now it's at the nil position, so now we are done, stop. But also each iteration we move S, so now we stop because fast reached the end, and so this is where we want to start reversing the linked list. Okay, and because the linked list is even, we don't need to worry about differences between both, because if it's even, we would have 5, 4, slow, fast, and then slow will be here, and then fast will be here, and then we'll have here. But you can see here this is not actually the middle, because here we have 3, and then here we have 3, but the problem here we have 2, here we have 1. So there's just that awkwardness with odd that we don't have to deal with here. But with this case, by just doing a loop like this, while we have fast pointer and fast.next, just before we reach the end, we keep moving slow once and fast twice. By the end of this iteration, slow will be in the position where we want to start reversing. Okay, so we just reverse this and apply this algorithm to reverse it, and then once we have it, we can just put both these pointers, and then each time just take the sum and check if it's the max. Okay, so yeah, that's pretty much the whole algorithm. Now let's just implement it and make sure it works. Okay, so now let's implement the solution we just saw in the overview. So first, we want to get to the middle of the linked list so that we can reverse. So we said we need both a slow and fast pointer. Initially, both are at the first position, and we'll keep going until fast reaches the end. We'll just do slow equal to slow.next, and then fast is going to be equal to, it moves twice, right? So like this. That's why also we are doing fast.next here, so that this doesn't become none, and this will be error if this is none. Okay, so that's why we are doing this here. And then once we do that, now we have the portion that we want to reverse starts at slow. So now we'll do the reverse iteration. And so we will reverse here by saying while current, and then our current node is going to be, because we want to reverse all the way to the end. So it starts at slow because that's where we want to start reversing. And previous initially before, it's just none because we don't want to reverse in relation to the previous one. Okay, we want to reverse only starting from this slow pointer here. And as we said, we want current.next to now point to prev, but we also want prev after this iteration to point to current, and then we want current to point to current.next, right? So that should be it. And so that's the reverse portion for the second half. So this is basically reverse second half. And now we can just have 2 pointers, left and right. So left is going to be at the start of the left side, so head, and right is going to be at the start of this reversed second half. And so to get pointer to it is just the last one, which is prev, right? And because at the end current would be none, and so the one that is not none would be prev here. And so we want to get the best, because those will point to the twin, the two values in each twin, and so we want to just get them maxed. And so here, while both exist, we can just take best as the max of the sum of the two, because those are the twins, plus write that val, and then at the end we want to return that value. Okay, let's run this. Sorry, here we need to move left and right. Okay, so we need left to be left.next, and then right to be equal to right.next. Okay, otherwise we will get it will be infinite loop otherwise. So if we submit, this passes our test cases. Okay. Yeah, so that's pretty much it for this problem. Now if we look at this, this is oven here, oven time, this is oven time, and then this is also at most oven time. So overall oven time here. In terms of space, we are only using pointers here, so it should be fine. It's better than the list approach. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.